Flagpole is on the roof of a building, and from a point 125 meters from the foot of the building, the angles of elevation to the top and bottom of the flagpole are 40 degrees and 37 degrees respectively. Find the height of the building and the height of the flagpole. So if you have a pencil, draw somewhere in the bottom corner. See if you can draw this picture on your own. And then I'll draw a picture and you can see, does your picture and labeling it match up with my picture? Because again, that's one of the hardest parts in these word problems, is being able to draw the picture yourself. So I'd like you to try, and then we'll draw it together. So we have a building, and on that building we have a flagpole, and the angle of elevation to the bottom of the flagpole and to the top of the flagpole, we're told that to the bottom is 37 degrees, and the angle of elevation to the top is 40 degrees. Here's our right angle, and from a point 125 meters away, so this is 125 meters. Now, there is a very common mistake in this question. And the common mistake is as follows. How many triangles did I draw? No. 3. Okay. There are 3 triangles that I drew, but only 2 of them have 90-degree angles. The little skinny one at the top does not have a 90-degree angle. But if you see the skinny one at the top as your second triangle, you're going to run into problems. You're going to run into problems because you can't use SOHCAHTOA unless you have a 90-degree triangle. But can you see the 2 triangles with the 90 degree? There is the big one to the top, and there is the littler one to the bottom. The big one to the top has an angle of 40 degrees. The little one to the bottom has an angle of 37 degrees. We do not use this triangle at all with the little 3-degree angle. On both of these triangles, this is 125 and this is 125. And I want to find both the height of the building. I want to find this. I'm going to call this X. I want to find the height of the building. I want to find this, which is Y. Can you see on my little 37, this is X. But on my 40-degree triangle, this whole height, which maybe I'll call H, is equal to X plus Y. The 2 heights put together. So can you see that you have enough information in both of those right triangles to solve for everything? In fact, the smaller triangle with 37 degrees, we could find the height of the building right away. So if I want to find the height of the building, and maybe in these questions that are a little bit more involved, sometimes it's nice if you give a little heading of what you're going to be doing. So in that second triangle with 37 degrees, I can find the height of the building. Maybe I put in brackets here to remind myself that's finding X. X is the height of the building. So I've got my triangle here with 37 degrees. X is the opposite. 125 is the adjacent. That tells me I want to use tangent. Write out my tangent definition. Multiply both sides by 125. I can go to my calculator, type this in. I have to often change between radians and degrees because my grade 12s are using a different measurement for angles. They use radians. We use degrees. You'll use radians, I guess, next year, because you'll be in grade 12 pre-calculus next year for some of you. Okay, so we get 94.194. That found the height of the building. Okay? We also need to find the height of the flagpole, but this little triangle that has the Y, I can't use because it's not a 90-degree triangle. I have to use these triangles. Can you see that if I use the bigger triangle and find the entire height, and if I have the entire height and I already know that X is 94 point something, I could just subtract and then find what Y is. So the next thing we're going to find is find the height of the building and the flagpole. That's our H, which we labeled right there. So again, I can use tangent. Tangent of 40 degrees is H over 125. Multiply both sides by the 125. And I get 104.887. Can you see that you could find out Y by taking the total height minus the height of the building? Again, on my calculator, if I don't want to round, I can just hit minus. That'll take to 104. On a graphing calculator, I can go up and select something, which keeps all its decimal places. You might have to write out all of those numbers. And usually, if you want to round to 3 decimal places, if you keep a couple extra, like 5 decimal places, you won't have a rounding error. So I push enter now, 10.693. These were the 2 answers we wanted to find. Since the word problem, it's nice to write a statement in the end. Height of the building is 94.194 meters. Did it ask what to round to? I should reread my question. It didn't say any rounding. If it doesn't say any rounding, I'd like you to go to 3 decimal places. And the height of the flagpole made sure that I included my units. Nice to put a box around my final answer. So I included my units, and I've answered the question with a statement because it was a word problem in the end. As the math gets more involved, like grade 9, you never had to do much stuff for figuring out a question. So you could show all of your work, but this one asks more than one thing. So we have to do a little bit of organizing, right? I organized height of the building and the flagpole. I drew out my pictures. I labeled things clearly. And again, this is the hard one when there's one 90-degree triangle embedded inside of another one. But you have to find the 90-degree angle triangles, because if you use a triangle that doesn't have 90 degrees, you're not allowed to use SOHCAHTOA. Next semester in grade 11, you will learn the sine law and the cosine law. They allow you to do stuff with triangles that aren't 90 degrees.